I need to say welcome to every one of you. In this video, I'm going to show you how to do topology optimization on this cylinder mounting bracket. Now, when you see the model, we have some features. The first one that I need to show you is the part that I'm going to preserve from the topology optimization. So here, when we see from the bottom, here we do have 4 elements for geometry or for bodies that is excluded from the topology optimization. So the place where I will apply the fixed boundary condition. The second feature here is this one is provided from the design of this bracket, and also here this one is the place where we apply the load for this bracket. Now to start the procedure, we first of all the part is on the modeling. Then after we have to come to the application, and then after we will go to generative design and click generative design. Then after clicking the generative design, so we see this interface of the Creo Parametric. So I'm doing this topology optimization on Creo Parametric 8.0. Now let me go to the process one by one. First of all, we have to apply the starting geometry. So for that, we have to go to starting geometry and click, and then come to the geometry. And when we hover upon the geometry, it shows some sign. So clicking that one. Okay, now that geometry is accepted. Here you got starting geometry is body 1. So the body 1 is the one that is selected from the screen. Then the second one is the preserved geometry, the one that I told you before. So click that this one and little bit bring this one at the end, and go and select the geometry one by one. Click this one, okay, and then after hold the control key, then select the second one. Second one is this one, then the third one, and also the fourth one. Now those 4 features, the first one is this one, the second one is this, the third one is this one, and the fourth one is this one. So those bodies are selected. Okay, then directly, now it is selected, and directly go to exclude geometry. When you hit this one, so it accepts the change that we provided for the first one. So it is body 2, 3, 4, 5 is selected as the preserved geometry. Okay, we finished for the design spaces. Okay, because we don't have any features or any body that should be excluded from the geometry, so we leave this one as it is. Then directly go to the constraints. Then for applying constraint, we come to the physics. Then here we do have constraints. Under constraint, we do have fixed boundary condition. Then hit this one. Okay, so we bring this one to the right end. Then now I'm going to select the boundary condition, the fixed boundary condition. So click this inner surface. Now 2 surfaces selected. The first surface is at the left, the second one is at the right. Then control here, hold the control and click the second and the third and the fourth. the fifth and the sixth surface, and this is the last two. Okay, so now this geometry is used as the fixed boundary condition, so we have to accept the change, say okay, and then after we finished for fixed boundary condition, go to loads, from loads go to force. Okay, then here I'm going to apply the load. Okay, select this surface and also this inner surface by hitting Control. Okay, now I'm going to apply the load amounts. Go to the directional component from that one, because the coordinate of this system is, the first one is x, second one is y. I'm going to apply the load along x-axis and the y-axis. So when you see the x-axis, this one should be minus 8. Let I change the unit first of all. Go to this one and change this one to kilonewton. Okay, and this one should be 8.84. okay, this one should be positive 8.84. the resultant magnitude should be 12.25 amount. So I decompose this 12.25 to the x component and the y component, because I found this 12.25 kilonewton from the papers that is published on this cylindrical bracket. Then hit OK. Then now we finished for the boundary condition. We directly go to design criteria and click this one. When you click this one, you have this star sign. Then click that one, and we have this box. So go to add materials. Then after, we are going to apply stainless steel material. Then go to standard materials. Then from this one, go to ferrous metals. Then here we have stainless steel austenitic. So click that one. I think it is good to apply stainless steel martensitic. Then click this one. Then double click this one. It will come to the bottom. Then here from this end, one part is selected. Hit OK. Then we provided stainless steel martensitic as a material. Then go to add constraints. From that one, I'm going to minimize. I'm going to apply the minimum radius of the features in the topology optimization. Hit this one and enter 5 millimeter. So this one is 5 millimeter is the minimum radius for the features. Then on the limit volume, so this is the amount that is retained, so it is 50%. Now I have to change this one to 30%. Okay, so this is the amounts or the volume that is retained from the geometry I provided. Okay, now hit OK. Now every parts of the process is applied. We have to go to the optimize icon here in the optimize button. So here you have to hit this one for optimizing. As you see here, it is optimizing. Now it is optimizing 129 out of 256 element. Now it is on 2/3 of the topology optimization process. Now the amounts of time that this optimization is taking is, at this point, is 2 minutes. Okay, it may take 3 minutes or 4 minutes, depends on the computational capability of the computer. Now the topology optimization process is finished. Now we have this geometry, optimized geometry. So it looks very attractive. Now for displaying the analysis, actually Creo Parametric optimization module integrates the ANSYS analysis. So for displaying the results of the analysis, we have to hit the display simulation results. Okay, we hit this one, and then after we see the magnitude of the stress, von Mises stress induced in the member. Here is the maximum happens at this place, this end. So that one is 138 megapascal. Now this one is for the von Mises stress. It is possible also to show the displacement. Okay, here we do have two alternatives. The first one is von Mises stress, and the second one is displacement. So when we hit this displacement, so the result will be for the displacement of the component. Okay, so it looks like this one. So this is all about the topology optimization of this cylinder mounting bracket. Okay, now this is the first weight is 1189.9 gram. That one is 1.18 kilogram, and the last optimized or topology optimized member is this one. Is 382.94% of the original one. It is roughly 32.2 because I entered 30% retainments of the mass, but because of some features, some constraint that I provided, it brings the total mass to 32.2 of the original one. So this is all about the topology optimization of this cylinder mounting bracket on Creo Parametric 8.0. Now if you do have question or any kinds of comments, I say welcome. So this is the end of the video. Okay.